Let's start by running the app and seeing how does it look. It's a simple page application with a single layout file right now. It's just showing a title and an avocado fact. Now let's go to the file and add a button. I already have it in my clipboard to paste it quickly, and I will also add this button in the tablet layout file. And now once I've added it, I'm going to start creating a variable to look up the button from my layout file. Button more, and import the file. Now adding a set on click listener. I'm gonna do a simple implementation with toast when the button is clicked. More button is clicked. It's a short toast and dot show. Oh, I made a mistake with the function name. It should be make text. Now let's run it again. And we see our toast. So all good. Now let's start adding some data to play with. I'm gonna create a function called getFacts. It's gonna return a list of strings, and we are gonna use a range to do this. So I return a list of strings by taking a range 1 to 10 and mapping them to a string fact of I, where I would be the range indexes. And I don't need to change this anything, no collectors or anything, because this is already a collection itself. So that's it, and we are done. Now we can change this to start creating a random fact generator. I'm gonna do a random, import it, give it a seed so that testing is more reliable throughout. Random.get a random number. We have 10 indexes, so we need to seal it at 10. This is my index, and now we can look up the text view for the fact and get the facts and pick up a random index and do it. We can run it again and we see what happens. We click it, and it changed. Now let's start making a async task to move this random fact generator to a different thread. Class get async facts. We're going to implement a async task. It's not going to need any incoming parameters, so void, there's no progress to be reported, and there's only a string output. So we have that in the function, void string. We need to call super, and we implement the only function. We're gonna move the function details from the set on click listener to the doing background. Fact text view is a UI thing which cannot be called from a background thread, so we are going to remove it and we are not going to worry about it for now. We are just going to return the fact as is, and that's it. The function is going to be moved inside the async task, um, and not be part of just the main activity. And let's call the async task and execute. So now it will run, but now we have not added how to update the UI. That happens on post execute. Now we have to look up the fact UI. The fact text view is a UI element that is not easily accessible in the async task. We're going to create a function called update text view that takes in a parameter new fact like string and no return value, and fact text view text value will be updated with the new thing. this will run to update our text view, and you think you can call that function directly from a sync task, but no, it cannot be. It requires a reference to the activity to call it. So here I'm creating the activity parameter that it needs and use activity to now call the function update fact, and this is the result. This result is what we returned in the do in background, and result is complaining because result can be a null. So one easy way in Kotlin is to do a let function and wrap this call in the let, but we still haven't added the Elvis operator question mark to help with the null check, and now it will be fine. Now we can run it and see what happens. One good thing that we have done in testing is give it a seed and the bound both, because now I know every time I run it, it's gonna give me 4 as the first output. So I always want to see fact 4 coming up in my screen to ensure like everything works as same as what I had before. It's running now, and I click the button and it shows me fact 4. So everything is hunky-dory, and we have done our first implementation of async task in Kotlin. Now let's add some logging to ensure we are really running these functions on different threads and not on the main thread again. So log.d, add the name of the async task, get facts, do an import for the log, and add doing background is running on the name of the thread. Now let's introduce a tag, a common variable for the logging. So the way we do it in Kotlin is using a companion object and declare our tag name of the sync task, and that's it. Now we're going to copy this function in exactly like this on post execute and check where is the post execute being run. Let's and click on the button, and we see that do in background is run on an async task thread, while the post execute is run on the main thread. This is what the power of async task is. The get facts, the data generation, and everything is happening on the background thread that keeps our UI much more responsive and achieving that 64 frames per second. Now we will move our data generation to a different class. Generally, you're not going to create the data right there in async task, but it's either going to be from a DB or from an API call. So I'm creating a facts provider file now, and quickly add into Git and moving the function from the async task to here. Nothing changes, everything is fine. Kotlin allows to have functions without any classes, so this is perfect. We just needed to generate some data quickly, and we have done it. Now let's close the data provider, close everything, and try and figure out the most important part. Activity. Is the activity really safe the way we have imported? No, because if user closed the activity before the data was back from the background thread, you will have a reference to UI that is no longer alive, and that's really bad. For that one reason, now we're going to use something called as weak references. Weak references are awesome to help us keep track of things that can become null down the line in future. We will transform our variable activity to a different a reference variable of type weak reference. Weak reference constructor would take the actual activity as the reference and keep track of it. And we update our post execute to use that and ensure like it's a safe call, that there is an actually activity that is present on which we can call an update function and do the UI update.